we're starting chapter 7. Honestly, I think chapter 7 is relatively easy, especially today's lesson. Today's lesson is very easy. However, people tend to make careless errors. We're talking about ratios and proportions, and when you've got to be careful how you set proportions up. Okay, you've got to set both sides up exactly the same way. And a lot of problems on your ACT, even though they're not geometry type problems, just math problems, can be set up as proportions if the information they give you is proportional. And so, this is a good lesson to learn. And so you need to make sure, as we go through this chapter, that you understand what the proportional relationship is and set your proportions up accordingly. A ratio is a comparison of two quantities. They're usually expressed in simplest form. Sometimes you read them A to B. Sometimes you use a colon between the two quantities. And sometimes they're expressed as a fraction. And again, they're typically in simplest form, reduced. What are some fractions that you use in everyday life? Can you think of something? Huh? In math? Oh, a half? Okay. But half, a quarter. Those are fractions. But what are we comparing? It's a comparison of two quantities. You're right, those are ratios. But what do we compare in everyday life? We want to make it real, right? So what are we comparing? What are some things that you compare in everyday life? Okay. It must do a lot of cooking, huh? True. You do, make ratios like, let's say, if you were going to clean up something, you might have a ratio of vinegar to water. Okay, you're going to clean something, a vinegar to water ratio. Okay, 1 to 10 or maybe whatever. Okay, I would venture to say that you probably don't do that on a regular basis. Sports, Mike, you're a sport, right? Softball. What do you do in softball? What are some proportions, or not proportions, ratios that you use? Okay, so give me an example of that. That one might be a little bit hard. What about if somebody says, how's your team doing? What would you say? Good. Okay, but would you say, oh yeah, my team is great? What would they ask you? Your record, right? Your win-loss ratio, right? If you were 10-0, you'd be definitely saying, well, we're 10-0, we're awesome, right? But if you were 2-9, you might not be, saying that as much. But we use that, right? I mean, the score of your for your team is a ratio, right? The number of points that one team got opposed to the other. In the classroom, you have your student-teacher ratio, okay? So if you go to the grocery store, you compare the price per pound, okay? So there's another ratio. So lots of different things that you use ratios with. Wilt Chamberlain. Has anybody ever heard of Wilt Chamberlain? You have? Probably one of the best basketball players of all time, I think. This is a true fact. He scored 100 points in a single game, and this is before the three-point shot. In that game, he made 36 baskets and 63 attempts. Find the ratio of baskets to attempts. What would we do? We want baskets to attempts. So how would we set that up? 36 over 63. Now again, you want it in simplest form. So what would you do to reduce that? Okay, you can divide them both by 3. That would be, 12 to 21. Okay, what else goes into both of those? Huh? 3 again. Okay, so 4 to 7. All right. So he made for every 7 shots, he made 4 of them. So he made 4 out of every 7 shots that he made. All right. Now, an extended ratio is a ratio used to compare 3 or more quantities. The expression A to B to C means that the ratio of the first 2 quantities is A to B, and the ratio of the last 2 quantities is B to C, and then your first and the last has a ratio of A to C. But they all have the same, proportional relationship. And so you're going to have some problems like this one on your homework, on your test, on your quiz, whatever it is that we do. In a triangle, the ratio of the measures of three sides is 4 to 6 to 9. And its perimeter is 190 inches. Find the length of the longest side of the triangle. Okay, so what we have is we have this triangle, okay? And it tells us that the perimeter is 190 inches. And it says the ratio of the three sides is 4 to 6 to 9. What they did is they took the actual length of the sides and they reduced them all by the same factor. Okay, so whatever these were originally, they divided them all by the same factor. Let's say x. Okay, and that's how they reduced them all to 4 to 6 to 9. But if we want to find out what the actual length of the longest side is, we have to blow them all back up by the same factor. Okay, so instead of dividing them all by the same number, we need to multiply them all by the same number. But we don't know what that is, so we're going to use an x. So we can blow each one of them up by that factor of x, and then we can add them together, and we know that their sum is equal to what? 190. So we're going to do 4x plus 6x plus 9x equals 190. And so we get 19x equals 190. We're going to divide both sides by 19. And so x is 10. Okay, which one of these is the longest side? The 9x, right? So what is that length going to be if x is 10? 9. So the longest side is 90 inches. Now, let's change the problem just a little bit, okay? Let's say that instead of these representing the side lengths, let's say that the measure of the angles were in a ratio of 2 to 6 to 10. 2 to 6 to 9. Okay, and this is the ratio of the angles. What would we do differently? You would set it equal to 180, right? Because the sum of all the angles is 180. The sum of all the sides is whatever the perimeter is, right? Okay, so you would do the same thing if they gave you angles as far as this is concerned, but instead of setting it equal to 190, you would set it equal to 180. Does that make sense? Okay? All right. Now I'm going to talk about proportions. Okay? A proportion is an equation that states that two ratios are equal to each other. And so we have A is to B as C is to D. To solve a proportion, or to determine if it's a true proportion, we do what's called the cross product. And to do the cross product, you take and you multiply your extremes and you set them equal to the product of your means. So that left diagonal is your extremes, the right diagonal is the means. So if I came over here, I could determine if this was a true proportion. If I did 2 times 9, that's 18, and 6 times 3 is 18. 18 is equal to 18. That's a true proportion. I can also use the cross product to solve a proportion, okay? And so I would take and multiply my extremes, 3 times 75, and that's going to be equal to 5 times x. 3 times 75 is 225. And then to solve it, if I divide both sides by 5, I get x equals 45. Same idea here, except now when I cross multiply, I'm going to have to distribute. Because if I multiply my extremes here, I've got 2 times the quantity, 3x minus 5, and then I've got 4 times a negative 13. I have to distribute that too. So I end up with 6x minus 10 equals a negative 52. And so then to solve it, I'm going to add 10 to both sides, and then divide both sides by 6, and x is negative 7. Questions on what we did there? I mean, y'all have been doing this for quite a long time, right? 6th grade, 7th grade. but you do have to show me your work. If all you do is give me x is -7, I'm not going to be able to count that right. Okay, you've got to show me your work. All right, especially on these work problems. I got to see how you're setting these up. Fernando conducted a survey of 50 students driving to school and found that 28 own their own cars. If 755 students drive to his school, predict the total number of students with their own cars. Okay, so what are we comparing here? What two quantities are we comparing? Okay, people that drive to school to people that own their own car. How do we want to set that ratio up? Which one do you want to put on top? Doesn't matter. The what? You want those that own their cars? Okay, so those that own their cars to those that drive, right? Okay? All right. So it says Fernando conducted a survey of 50 students driving to school and 28 own their own cars. What would that ratio look like? 28 to 50. It says if 755 students drive, if 755 students drive to his school, predict the total number of students with their own cars. How would you set the other side up? X over 755. Okay. All right. So the main thing that you got to make sure is when you set this proportion up, if you're setting up the left side as own to drive, you've got to set up the right side as own to drive. Okay. All right. So we cross multiply, and 28 times 755 is 21,140 equals 50x. We're going to divide both sides by 50, and it ends up being 422.8 students, which is about 423 students own their car. I think that's a pretty big number, don't you? I think their parents probably would own it, right? Not them. I don't know, I may be wrong. Alright, let's look at the last one. A twin-jet airplane has a length of 78 meters and a wingspan of 90 meters. A toy model is made in proportion to the real airplane. If the wingspan of the toy is 36 centimeters, find the length of the toy model. Okay, what are we comparing here? What'd you say? The length to the wingspan? Okay, all right, that's one thing that we're comparing. The length to the wingspan. We're also comparing an actual airplane to a toy airplane, right? Okay, so we really got two different things that we're comparing. But let's go with length to wingspan. Okay, it says that in a twin-jet airplane, the length is 78 meters and the wingspan is 90. So we could set up a ratio of 78 to 90. Okay, that's in the actual airplane. Then we go to the toy model. And what do they tell us? What do we know? We know the wingspan is 36, but we're looking for what the length is, right? Okay, so wingspan is going to go on the bottom. This wingspan's on the bottom. And the length is going to go on the top. Okay, well, we can cross multiply here. We're going to come back and talk about something in just a second. But if we cross multiply, we end up with 2,808 equals 90x. And we're going to divide both sides by 90. And we end up with 31.2 centimeters. Now, did you notice that this was meters here and this is centimeters? Does that matter? Not really. We are comparing length to wingspan on one side and length to wingspan on the other side. So if we've got meters to meters, we're gonna have, we can have centimeters to centimeters. Okay, as long as it's proportional, we're okay. Okay. You just have to realize that since this left side represents the actual, it's in meters. The right side represents the toy, and it's in centimeters. So when I get my final answer, it's going to be in centimeters. Okay. Now, I could have set my problem up a little bit differently. I could have done the actual. We'll do toy. Let's do the actual airplane to the toy or the model. actual airplane to the model, okay? And one side would have represented the length, and the other side would have represented the wingspan. So if I looked at the length, I would have done 78 to X. And if I looked at the wingspan, it would have been 90 to 36. It's still actual to model for the length and actual to model for the wingspan. Since my top numbers are length, my bottom numbers are wingspan, you have meters to centimeters, meters to centimeters, and you're okay. That's okay because it's proportional, all right? So it'll work. But it only really works like that if it's proportional, so you got to make sure that you're careful there. But I could cross multiply here, and I'm going to get the same answer, aren't I? Because I'm going to multiply 78 and 36 and 90 and X. So I'm going to get the same answer either way that I do it. All right, any questions on what we did today? Pretty simple, okay? Just make sure that you show your work, all right? And make sure that you look at what you need to measure that it's in, okay? You just have to make sure that at the very end that everything is kosher. Sometimes you do have to change. When we talk more about scale, there are times when you do have to change the units of measure, okay? We'll talk more about that later. Any questions? All right, your assignment is on the board.